Hi, a very good morning and good afternoon to panel who watching this presentation video. My name is Table Jing and my metric numbers is CN170122. I'm a student from Department Mechanical Engineering Technologies. My supervisor is Dr. Siti Hana binti Nasir. Now, I will present about my PSM 2, which is the review study on the effect of needle punching machine parameters on the filtration efficiency of non-woven fabrics used for development of face masks. So basically in PSM 1, I expect that I can conduct the experiment in campus to investigate the impact of machine parameters on the physical properties and filtration efficiency of non-woven mat. Because campus have the needle punching machine, so I didn't conduct the experiments. However, because of a trend of COVID-19 became serious, so I was unable to go back to campus. Thus, my supervisor gave me suggestion to continue my final year project, and at the end, we decide to do a review study, which is review study is collect the data from previous study by other author and analyze them and make a conclusions. So now we look at the extract of my PSM. So face masks were produced around a century ago as a method of protecting people from the risks of infections. Most surgical masks are made using non-woven manufacturing methods such as needle punch. So this review study was conducted by searching based on data from other research and compiling the data through a series of papers. The literature search used for database, which are Google Scholar, SAGE, ScienceDirect, Elsevier, and 30 articles were identified. At the end of this review study, the machine parameters and fiber parameters such as high needle penetration, high needling density, and hollow cross-sectional shape of fiber will suggest for non-woven fabrics used for face mask production. Because it provides better physical properties and optimum filtration efficiency such as high fabric density, small pore size, lower porosity, higher air permeability, and excellent water resistance. For the introductions, so most of our surgical masks are made using non-woven method. So what is non-woven method? Non-woven are long fiber that have been bound together using various methods such as dry land or wet land. So needle punching non-woven fabrics is one of the dry land method And this study provide a general review on the effect of needle punching machines parameters on the filtration efficiency of non-woven fabrics used for development of face masks. The machine parameters and fiber parameters such as the depth of the needle penetrations, needling density, and fiber cross-sectional shape, and the most optimum performance of the non-woven mat that is suitable to be produced as a face mask will be selected at the end of these reviews. So now we look at the literature. So basically, face masks are used to protect the wearer by covering their nose and mouth to create a barrier that limits the transmissions of bacteria between healthy and sick person. Face masks are made using non-woven method because they have excellent air permeability, low in cost for productions, and optimum filtration efficiency depending on the characteristics of the non-woven mat produced. So the needle punching non-woven fabrics was produced by strengthen the web by using mechanical mechanism until the fiber become a complete fabrics. The fiber used in a face mask is mostly polyester. Polyester fiber is a man-made fiber that was produced with long chains of synthetic polymer. It formed from many molecules combined. Okay, so now we look at the needling density. Needling density is a punch number per cm square. The compactness of the fiber in web was affected by needling density. And then lastly, for the cross-sectional shape of fiber are trilobar, hollow and round shape. Those fiber cross-sectional shape may affect the properties of synthetic fibers. And then we look at the depth of the needling penetration. Actually, it's the distance that the needling passed through the web. So when the depth of the needling penetration increase, the more the bulk will pass through the web of the fabrics. So now we look at the methodology. So first we need to fix the criteria before we doing the research from website, such as what kind of fabric I'm gonna study, what type of machine parameters and fiber parameters will select, and what kind of physical properties of fabric we gonna analyze, and so on lah. So we need to fix the criteria first. So second, the preliminary study and data collection. The data is collected from past research that related with my study by searching from website. And then after collect the data, and then we extract the data. We only extract the data that we want. Only extract the data that we want. After that, based on the finding from previous study, we analyze the impact of the machine parameters and fiber cross-sectional shape parameters based on the finding from past study. And then lastly, we writing the discussion and make a conclusion in PSM reports. So now we look at the result and discussions. So as you can see, with the various parameter of needle punching machines and fiber cross-sectional shape, the change of physical properties and filtration performance of non-woven fabrics occurs. As you can see, when the non-woven met with high needle penetrations, high needle density, and hollow cross-sectional shape fibers, the non-woven fabrics were produced with low thickness, high density, strong tear strength, small pore size, excellent water resistance, and high air permeability. This may be due to three factors, that is the change of fabric compactness, the change of fabric consolidations, and the fiber interlocks when the parameters and fiber parameters change. Lastly, for the conclusion for my PSM2, so we can conclude that high needle penetration, high needling density, and hollow cross-sectional shape of fiber will suggest to become the non-woven fabrics parameters that are used as a face mask productions. Those parameters provide better physical property such as higher fabric density, small pore size, low porosity, high air permeability, excellent water resistance, and optimum filtration efficiency. So however, the filtration efficiency of the non-woven fabric will drop slightly when the fabric thickness decrease, and also air permeability of the non-woven fabrics will drop when the needle penetration increase. But other than that, overall, the fabric performance is good and suitable to be used for face mask production by following these machine parameters and fiber cross-sectional shape. So this is all for my presentation for PSM2. So thank you for watching.